Hi, for this exposition, we're going to present some topics related to security vulnerabilities, threats, and countermeasures. Today, we're going to be speaking Vanessa Brenes, Estefania Marin, Megan Miller, and Daniela Montenegro.
Introduction. In the computer system that are developed, it is very important to attack security aspects, such as trying to cover the basic principle and protection mechanisms. This will make it possible to avoid vulnerabilities that will become threats. However, these should not be the only elements to consider, but it is of utmost importance that attention be paid to the system outside. B. Ensuring that higher-level system protection controls are not created on an unstable and insecure basis. Assess and mitigate security vulnerabilities. It has been determined that the more complex a system is, the less security it has, which is a huge problem, since the more complex it is, the greater the number of areas that can be attacked. It is essential that professionals in this area must have basic knowledge and experience to solve a problem that originates at the system level. In this section, we will talk about the security problems that exist in the physical components of a computer, hardware and firmware. To do this, we must remember that the hardware encompasses of the tangible material of a computer, while the firmware describes the software that is stored in the RAM chip. In the case of hardware, we will review some security problems that exist in these different components. In the processor, it is possible to consider the protection rings as a protection mechanism which has the ability to organize the code, components, and applications in the OS in construction rings, which allow the OS to be protected and isolated from users and applications. In the storage media has a protection mechanisms, it will be possible to use tools that are responsible for eliminating all traces of the files, which will be able to correct the problem in terms of the information that is still stored in the secondary storage. And in the input and output device, it will be possible to implement tools and protection mechanisms in the various devices. Screen printers and keyboards, giving for each one their different problems, such as the monitor when other people can intercept the information shown in the screen. In the case of printers, external persons might have access to confidential information since this device retains copies of prints. In the case of firmware, we will indicate some security problems that exist in these different types: BIOS and device firmware. BIOS. There is an attack now as flashing, which by means of the installation of the malicious variation of the BIOS, it is possible to introduce malicious characteristics in the device. Device firmware. Hardware device need limited processing power that allows them to fulfill their tasks and minimize the load on the OS. On the other hand, we will talk about client-based systems. It is important to emphasize that normally the attacks are aimed at the server, but when attacking from the client side, it means that the main objective is this client. A client-side attack will put the user, their data, and even the system at risk. Some of these vulnerabilities occur at the level of applets and local caches. Applets. A remote system might send code to the local system for executions. This code might be malicious and insecure. Local caches. An attacker poisons the ARP cache when a client performs the ARP broadcast query. The attacker takes advantage to send a forced response.
Now we're going to present some topics related to server-based systems. Database security is a very important part in an organization where large sets of data are used as essential assets. Without this, confidential information could be put in a risk. Some topics related to database security are aggregation, attacks used to collect numerous low-level security or low-value items that then will be combined to create something of a higher security level or value. We have inference. These attacks involve combining several parts of non-sensitive information in order to gain access to information that should be classified at a higher level. We have data mining. These techniques allows analysts to go through data warehouses and search for potential correlated information. Then we have data analytics. It's the science of raw data examination, and its objective is to extract useful information out of a bulk with the goal of assessing compliance, improving efficiencies, productivity, and detecting violation. This is also known as big data. We have data warehousing. These are large databases used to store large amounts of information from different databases. And finally, we have data dictionary. These are used to store critical information about data, including usage, types, sources, relationship, and formats. Parallel data, also known as parallel computing, is a computation system designed to perform numerous calculations simultaneously by dividing large tasks into smaller elements and then distributing them to a different processing subsystem. Here we have asymmetric multiprocessing. These processors are often operating independently of each other. Most of the time, each processor has its own operating system and task instruction set. They can execute only specific code or operate on specific tasks. We have symmetric multiprocessing. Each processor shares a common operating system and memory, and all of them work on a single task, code, or project. And an alternative is massive parallel processing, where numerous SMPs systems are linked together working on a single primary task across multiple processes in multiple linked systems. Then, for distributed systems and endpoint security, this means processing and storage are distributed on multiple clients and servers. So all the information that is going through must be properly secured and protected. Some of the policies that clients must follow in order to keep safe their contents and their user activities that we define are: email must be screened so that it cannot be a vector for infection by malicious software. The second one, download upload policies must be created so that incoming and outgoing data is screened and suspect materials are blocked. Systems must be subject to robust access control, which may include multi-factor authentication to restrict access to end user devices and to prevent unauthorized access to servers and services. The fourth one is restricted user interface mechanisms and database management systems should be installed and their use required to restrict and manage access to critical information so users have minimal but necessary access to sensitive resources. And last, file encryption may be appropriate for files and data stored on client machines. Then we have cloud-based systems. So it refers to computing where processing and storage are performed somewhere over a network connection rather than locally. The difference with cloud computing is that the local operator does not need to be locally. Some concepts in cloud computing are platform as a service, where computed platform and software solution is stacked as a virtual or cloud-based service, provides all the aspects of a platform, meaning the operating system and complete solution package. Then we have software as a service. This provides an on-demand online access to specific software apps without the need for local installation. And last, we have infrastructure as a service. This one provides on-demand operating solutions and complete outsourcing options. Some of cloud services offered are The private is a cloud service within a corporate network and as isolated from the internet, is for internal use only. We have the public is a cloud service where the general public can access to it over an internet connection. We have the hybrid. This service is a mixture of the private and the public cloud components. It can host a private cloud or a public one. And last, we have the community. This service is environmental, maintained, used, and paid by a group of users for their shared benefits. Now, grid computing is a form of parallel distributed processing that loosely groups a significant number of processing nodes to work on specific task processing objective. One of the concerns towards security on grid computing is that most of the projects are exposed to the world. And we have Internet of Things is a new class of smart devices that need to be connected to the internet in order to provide automation, remote control, or artificial intelligence processing. These type of devices are adaptations of actions that have been performed manually.
Okay, now we are going to talk about access and mitigation vulnerabilities in web-based systems. So we have the web application completed to a traditional security model. Therefore, vulnerabilities include concerns related to extended markup language and security association markup language. So such concerns or vulnerabilities are discussed in the Open Web Application Security Project. It is a non-profit security project that focuses on improving security for online web or web-based applications, and it also a large community that works together to freely share related information, methodology, tools, and techniques to improve coding practices and more secure deployment architectures. So now we have some of the major web risks that are disclosed. Um, First, injection is attack that is any exploit that allows an attacker to send code to a target system to modify its operation and or poison. And curve is dataset where there is a wide range of possible injections attacks. Some examples are SQL injection, LDAP, XML injection, command injection, code injection, and file injection. Now we have XML explosion. That is a variant of SQL injection where the target of the backend in XML requests a form of programming attack that is used to falsify information to be sent or to a visitor or to cause their system to deliver information without authorization. Next, we have cross-site scripting is a form of malicious code injection attack in which an attacker is capable of compromising a web server and injecting its own malicious code into submitted content to other visitors. Finally, we have cross-site request forgery. Is an attack similar to a nature to XSS. The attack targeting the visiting user's web browser rather than the website being visited. Uh, the main purpose of XSRF is to trick the users or the user browser into carrying out action that they did not intend or will not have authorized. Now we have assessing mitigate vulnerabilities in mobile system. So we have the smartphones and other mobile devices present an increasing security risk that can interact with the internet and corporate networks. Malicious intruders can enter malicious code from mobile phones, audio players, digital cameras, memory cards, and USB drives. Some important aspects in the evaluation and mitigation of vulnerabilities in mobile systems are device security, lockout, screen lockouts, bring your own devices concern, GPS, authentications, device access control. There are more elements to consider, but for general knowledge purposes, these are the ones that shown. So next, we have assess and mitigate vulnerabilities in embedded device. So we have two systems. The embedded system is typically designed around a limited set of specific functions in relation to the largest product of which it is component. Um, the second one is a static environment. Is a set of conditions, events, environment that do not change. In theory, once understood, a static environment does not offer a new or difficult element. Continuity methods for installing a static and integrated system. Security concerns regarding static embedded system include the fact that most are designed with a focus on minimize cost and extraneous features. Now we have some important elements are mentioned to assess and mitigate vulnerabilities in embedded devices and cyber physical systems, network segmentation, wrappers, control redundancy, diversity, security layers, application firewalls.
When security mechanics are implemented within an operating system, exists a simple rule: you don't have to trust in the software. Exist general security rules that professionals in the computer industry must respect. There are two main areas. The first one is essential security protection mechanics, and are five techniques. The number one is layering. This type can be presented through two ideas: a structure similar to the ring model, and the other is levels. The thought of a multi-layer or layered system equals the center ring of a guard ring scheme, and the bottom of the layered or multi-level system is the same as the outer ring of a protection ring scheme. The number two is abstraction. Is a measure in which media access to data or service is given. For example, in many applications there is a user node. This use the system calls to request service or data in administrator mode. It doesn't have direct and immediate access. The number three is very simple, is data hidden. And this the data in one security level are not visible to process running in other security levels. Number four is process isolation. This requires the operating system to provide separate memory space for the instruction and data for each process. It is important for the operating system to prevent a process from reading or writing data that belongs to another process. Some modern operating systems apply this technique using virtual machines, one for each user or process. And the number five is very similar than this, but in this technique, the requirements are present with the use of a physical hardware controls and not by an operating system. Their complexity and cost are very high, and for this reason, this type of implementation are rare. Generally applied when the information is very sensitive. For example, in a sector such as national security. The second area is this: security police and computer architecture. Mechanics that are extension of the basic doctrine of computer security. These are some techniques related to architecture and design. The number one is principle of least privilege. And when designing operating system process, it is mandatory to ensure that this process runs in user mode whenever possible. The number two, separation of privilege, and this technique needs granular access permission, different permission for each type of operation. The function should not be mixed. For example, the web designer doesn't have to do software architecture process. And the number three is accountability. Accountability is an essential component of any security design. The success of the accountability is obtained with proactivity, complaints, traceability, and periodic reviews.